Assalamualaikum and welcome to Group 2 project presentation. Before we start our presentation, let us know the members from Group 2. Assalamualaikum and a very good day to everyone. My name is Tajumaidin bin Sin Ibrahim. My matric card number is AD170233. I am from Faculty of Mechanical and Manufacturing Engineering.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adib Nakiuddin bin Ruslan. My matric number is AD170057.
Assalamualaikum and good evening. My name is Muhammad Alif bin Ma'amin and my matric number is AD170048.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Ami bin Abdul Razak with the matric number AD170177.
The presentation outline consists of introduction, conceptual design, electrical discharge machining, and finally conclusion and recommendation. As you can see here, this is the group project organization from Group 2.
Today I will talk about the introduction of our group report presentation. Firstly, our group has required to produce a plastic key tag using the method of plastic injection molding. The plastic key tag is a type of tag that is made up from plastic material, which is the key can be attached to the tag to address a small knot or indicate the identification of the key itself. And then the plastic injection molding process, a widely used polymer processing operation which is include 3 stages, which is filling, packing and cooling. The additional design made by our group makes the key tag has an additional function, which is as a bottle opener. So our key tag is a 2-in-1 product, which is as a key tag and also as a bottle opener. And then our group has choose ABS plastic and also the polycarbonate plastic, which is we mix these two material to produce a strong solid plastic, and it will be used as the main material for our plastic injection molding process.
Hi, so as for my part is the conceptual design. So conceptual design consists of 3, which is the product that refers to the plastic key tag, and then next will be the mold cavity, which refers to the workpiece, then followed by the electrode, which refers to the tool. So as for the product plastic key tag, in this project it is necessary for our group to design a plastic key tag using a method of plastic injection molding. So what is meant by plastic key tag and what is the function of the plastic key tag? So to answer that question, plastic key tag is the tag that is made up of plastic material to which the keys are attached to the tag. So the function of the key tag is mainly to address a small node or to indicate the identification of the key itself. So the additional design that my group created is to provide the additional function for the key tag that works as a bottle opener. So design of that we propose was made up with the method of plastic injection molding to add the feature of bottle opener to the key tag. So besides the ordinary use of key tag, which will be the tagging a small label to the users, so by inserting the paper into the paper slot on the key tag, the application of additional feature makes the key tag may be applicable for bottle opening. As you can see here, this is our proposed plastic key tag that were initially have discussed by Group 2. As you can see here, this is the plastic key tag base. Here is the plastic key tag cover. This is the final assembly product of plastic key tag after combining the base and also the cover. Moving on to the next, which is the mold cavity of a workpiece. So the design of the mold cavity is fully dependent on the size of the key tag product, as a key tag product will be considered by using the molding shrinking factor of the plastic material that has been chosen for the project. After certain consideration, we chose the steel as the the material for the mold cavity, as the material is most common and majority of the industries uses the material for the mold cavity. So the mold consists of structure such as mold cavity, mold core, sprue, runner and gates. So the function of the mold cavity is to mold that gives item its final exterior shape, while the mold core is give the product and item that produce the internal shape. The sprue is a tapered bore barrel that injection units exist that direct melt to the path line of the mold. The runner is the path taken by the molten plastic as flows from the sprue to the gates. The gates is a tiny aperture in the polymer that melts allows it to enter the cavity. As you can see here, this is the workpiece bottom and also this is the workpiece top. So the last part, which is the electrode or the tool. So the design of electrode for this project is created to the shape of workpiece into the shape of key tag. So the electrode's function is to conduct the electrical charges and the electrode, the workpiece, to the appropriate shape. So typically electrode are made up of metals that has a high melting point and good electrical conductivity. So material of electrode for this project is chosen as graphite because it applied for large volume or the parts that gives the fine details. So the graphite electrode gives a low wear and excellent machinability. Graphite is also a substance that utilized as a tool material in EDM because it has a high conductivity, high resistance to corrosion and high resistance to wear capacity. To show you the clear picture of electrode, now you can see here is the electrode bottom and also here this is the electrode top. That's all from me. Thank you.
So today I'm going to present the electrical discharge machining, which is die sinking. EDM die sinking machine consists of electrode and workpiece that are submerged in an insulating liquid such as oil and other dielectric fluids. The electrode and workpiece are connected to power supply, and then the electrode pushed to the workpiece. The electric breakdown occur in the fluid and forming a plasma channel and a small spark jump. Next is the working principle of EDM. There are four main working units, which is power supply unit, direct fluid reservoir pumps, filter and control valve. Next is the working holder, tool holder and table. Next is the servo control mechanism as shown in the figure. So for the process parameter of EDM, this controlling parameter divided into electrical parameter. So for the electrical parameter, there is the torque voltage and peak current playing an important role in output performance measure. So here we discuss about the effect of the electrical parameter on the various performance measure. So for the discharge voltage, we use around 100 voltage to 400 voltage. So for the peak current, we use to 20 ampere to 40 ampere. For the pulse on, is between 10 microsecond to 200 microsecond. For the pulse off, is between 20 microsecond to 300 microsecond. And last is the electrode gap, which is 5 micrometer to 40 micrometer. Next is the tool electrode. So in determine the overcut, the first thing that we consider for the electrode designing is by using the overcut. So for the formula overcut is OC equals to DJT minus DT divided by 2, which is DJT is cavity size produced in the workpiece, meanwhile DT is the tool size. Next is the feed rate. Feed rate is the speed at which the cutter engages the part and typically measured in units per minute. The formula for the feed rate is F equals to D times H divided by MRR times 2. So F is the machine feed rate, D is diameter, H is the thickness of the workpiece, and MRR is the material removal rate. Next is the workpiece. So the actual shrinkage of a plastic part can be expressed as SA, which is actual shrinkage of a plastic part. If it's not possible to measure part dimension under molding temperature condition, so we use the cavity size, which is SC, that undergo room temperature condition. Next is the surface roughness. Surface roughness is a specimen with different parameter on electrode that we measure. So the surface roughness increase when pulse on time and peak current increase due to the longer time for machining, which led to higher possibility of double sparking and localized sparking occurring. So wire tension and wire feed rate were the most significant and influencing parameter for the surface roughness. And for the last part is dielectric fluid. For this project, we used deionized water, which is primarily tap water that has been filtered through deionization resin to reduce its electrical conductivity. Due to deionized water reduce the electric strength, the discharge sparks ignite more easily at larger working gaps than with dielectric oil. In comparison to dielectric oil, deionized water affect higher surface quality and a higher material removal rate. The flow rate of the dielectric fluid will be the range from 30 ml per minute to 325 ml per minute. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Ami bin Abdul Razak with the metric number 8170177. So, I will explain about the procedure of machining for our group project. So, the dry and near dry EDM milling experiment are conducted on a Vanguard 150H CNC die sinking EDM machine from EDM Solution. A rotary spindle Rotobore RBS 1000 with through spindle flushing capability is used to hold the tubular electrode. As shown in figure 1A, show the setup of the spindle, 2 electrode and medium dielectric inlet. The spindle rotates the tool electrode to maintain uniform tool wear and enhance debris removal. The dielectric fluid, which can be in the form of liquid gas or liquid gas mixture, is delivered through a tubular tool electrode. The liquid gas mixture is generated by an Amcol 6000 pulse spray generator as shown in figure 1B. Designed for minimum quantity lubrication MQL machining application. In this study, the input liquid flow rate is fed at 5 mm per minute. Figure 1C show the setup of a nozzle to deliver chill eject around -3 degrees Celsius from an Azer model 5215 cold gun system. The external eject helps to solidify and flush away the molten debris. This is especially useful in the high MRR process, which generate a large number of molten debris. So as you can see here, these are the figure for the dry and near dry EDM experimental setup. So for the procedure of the machining, first the workpiece material is AISI H13 to stay deposited by the DMD process is placed on the cutting board. Second, the copper and graphite, the two most commonly used electrode material with a tubular electrode of 3 mm outer diameter and 1.5 mm and 1 mm inner diameter for copper and graphite electrode respectively is being set up. The cutting platform happen in a liquid dielectric which has air, oxygen, nitrogen and helium in near dry EDM, where deionized water and kerosene are selected. Fourth, the depth of cut is set up to be varied between 0.1 to 0.6 mm in roughing operation to achieve high MRR. The AISI H13 tool steel is mounted on the T-slot table position and clamped at the desired location. The electrode, which was designed to match the cavity mold, was fastened to the V-block and its alignment was inspected with the tri-square. The negative polarity or cathode is applied on the tool electrode in all dry EDM for reduced tool wear. So, for the precautionary tips for handling EDM, first, you must keep your machine well maintained. Your machine should clean and lubricated when it needs maintenance. Make sure the work is done by well-qualified professional. Second, you must know your machine. And third, keep the area around your machine free from flammable material. And fourth, stay alert and give your undivided attention to machining. And fifth, wear appropriate eyewear and never look directly at the spark. Sixth, wear closed-toe, non-slip shoe with rubber sole. Shoes should be comfortable as well, since you may be standing for extended period of time. So for the cutting procedure for upper and lower cavity, first, the parameter of the cutting process is all set to the desired value as it is presented in figure 5a. Second, the axis XYZ of the machine needs to be calibrated to 0 value as shown in figure 5b. Third, the axis of XYZ will be set and then set the pulse current for the electrode to the desired value or shape. And lastly, the machine will be running until the desired mold shape is achieved. That's all for the procedure of machining. Thank you.
As for the conclusion, the development begin by determining what is the best design of keytag that every people can have, and then by doing some research, survey and analysis about the keytag, we upgrade and add the function and design of the keytag, such as we provide additional features for the keytag as the button opener, so this keytag will be 2-in-1 product. And then the selection of the material is also important because it can estimate the cost, what will happen next, and planning can be perfect to create the keytag. And last but not least, for my conclusion, our objective has been achieved parallel to our scope of work in this developing process. For the part of recommendation, I would like to come up with 3 points, which is the first one is the additional function of the keytag can help make the keytag has special function, which is as the button opener. But it is better if the material of the keytag is strong enough and hard as the button opener, which is it can be used for hard surface, so it can open any kind of button. And secondly is we should add another cover for the keytag in terms of safety factor. And the last recommendation is we could apply joining method to connect the base and cover of the keytag, as it is only connect using magnet. So the connection will only last until the magnet field is there to join the component. So that's all from me. Thank you.